Hello, children. How are you all? Okay. In the next topic, we will discuss the electric field. Before going to discuss electric field, already we have seen about Coulomb's law. What Coulomb's law says, there will be some force of attraction or repulsion between any charge, any two charges, whether it may be like charges or unlike charges. Actually, what is the meaning of electric field? Electric field means there will be a space around a charge, the space around a charged body, there will be some electric field is present. If you take a positive charge, if you take a positive charge, then there will be electric field is produced. Because of this electric field, we have attraction force or repulsion force. Means every charged body creates some electric field. Suppose if you place a positive charge, then the electric field may be in this direction. Okay, they are moving like this. The electric field is moving away. Electric lines are moving away like this. That's why if you consider the direction, this is what we have the direction like this. You have to consider here. Means what? Every charge creates electric field around itself. First we will write that one. First one is every charge creates an electric field around itself. This is what we have, electric field. Okay, like this we can define here. Suppose if you want to place how the force is there, already we discussed in Coulomb's law, there will be some attraction force or there will be some repulsion force. If you want to find out the attraction force or repulsion force, or if how we can prove that there will be some force is there, and that was explained by electric field. Means here one more definition, here we define electric field is the space around a charge, the space around a charge in which its influence can be felt. Like this we can write, the space around a charge in which its influence can be felt. But దాని యొక్క influence, suppose if you place this is a charge, there will be field is there. Because of this field only we can say that there will be some influence is there. Okay, suppose if you place a bar magnet, if you take a bar magnet like this, if because of this bar magnet, there will be some influence of this space around the bar magnet. Suppose if you place any iron filings, like here if you place any object iron filing, then immediately it will attract. Suppose if you place here, it doesn't attract. That means there will be some influence is there. How the influence is present? Because of this bar magnet. In the same way, here also there will be a positive charge. If any positive or negative, whatever it may be, if there is a positive charge is there, because of this positive charge, there will be some place is there, the space around this charge in which there will be some influence is present. Because of this influence only we can have this electric force. Suppose if you place a small test charge, this we are calling it as a test charge. Okay, we have a small test charge, we can say this we can write as a test charge, positive టెస్ట్ ఛార్జ్. పాజిటివ్ టెస్ట్ ఛార్జ్ అంటే ఒక పాజిటివ్ టెస్ట్ ఛార్జ్ని దీని దగ్గరలో కనుక మనం పెడితే ఇక్కడ ఏం జరుగుద్దంటే ఈ పాజిటివ్ టెస్ట్ ఛార్జ్ వల్ల వీటి మధ్య ఫోర్స్ ఆఫ్ రిపల్షన్ అనేది ఇలా రావడం జరుగుతుంది. ద ఫోర్స్ ఆఫ్ రిపల్షన్ అయితే. And you can also know that because of this positive test charge, how the positive test charge means the test charge whose charge is nearly equal to zero, means there will be no influence of this one. అంటే దీనిపైన ఇన్ఫ్లుయెన్స్ జరగవచ్చు కానీ దీనివల్ల ఇన్ఫ్లుయెన్స్ అనేది ఉండకూడదు అనేది మన కన్సిడరేషన్. We have to consider that because of this charge there will be some influences should not be there. That's why whose charge is almost tends to 0. That's why we can write limit q naught tends to 0. That means there will be no influence of this charge, presence of this charge on this charge. Because here, because of this positive test charge, there will be some influence is there. Because of this influence, there will be some repulsion force because the force is moving in this direction. This is what we have, the second definition we have written here. That means the electric field in which the space around the electric field in which its influence can be traced out. That is also we can observe here. Okay, this is what we have positive test charge. First you write this one. The space, we can define the electric field as the space around a charge in which its influence can be felt. Influence can be felt. Okay, influence can be felt. How we can say? Because of another charge only we can say there will be force of repulsion or attraction is there. That's why we can write influence can be felt by another charge. అంటే ఇంకో ఛార్జ్ పెట్టినప్పుడే మనకు దీని యొక్క ఇన్ఫ్లుయెన్స్ ఇంతవరకు ఉంటుంది అనేది మనం చూడవచ్చు. And here how the electric field lines or the electric force is normally away from the charge. Okay, outwards from the charge. Like this we can write here. Okay, radially outwards. The direction is radially outwards. Suppose if you take a negative charge, if I place a negative charge like this, then how the lines are there? The electric lines are, electric field means electric lines, and these electric lines are, how the electric lines we have? Like this we have, and the direction of these lines must be in this direction. Okay, like this. The same charge if you place at this place, at this point, this we can consider it as q naught, then how the force is in this direction. Okay, the force is in this direction because it is a positive test charge. No, this is what we have, positive test charge, and the direction is radially inwards, like this we can write here. Okay, positive test charge and the direction is radially inwards. Like this we can write. This is what we have, electric field. Electric field means every charged body, every charged particle creates some electric field around itself. Because of this presence of electric field, there will be some influences there. Because of this influence we have force. If you place another charge, then the force may be attraction force or the repulsion force. Okay, like this we can write. Okay, first you copy this one. Okay, after this we can write one more important topic here. Intensity of electric field. Intensity of electric field. Intensity of electric field. intensity of electric field due to intensity of electric field due to positive charge due to positive charge q naught due to positive charge at a distance r at a distance r at a distance r from it. Okay, we have to find out the intensity of electric field. Suppose if you place a charge, then what should be the intensity of electric field? That I have to find out here. Okay, first we will draw. This is what we have, a positive charge. You take a positive charge. ఇక్కడ తీసుకున్నాం. If I want to place a test charge here, okay, q naught, which is at a distance r, then how we can find out the intensity of electric field? Intensity of electric field due to positive test charge at a distance r from it. Okay, how can you find out the intensity of electric field? First of all, we will find out, suppose if we have, there will be some unit positive. Here we can say that, how can you find out the force? Force is equal to k into q naught by r square. F is equal to q naught by r square, where k is nothing but the constant 1 by 4 pi epsilon naught. Here, for q naught charge, the force is F is equal to q naught by r square. Then what is the force per unit positive test charge? Unit positive test charge. The q naught charge వల్ల వచ్చే force ఏమో ఇదం. For q naught charge, okay, the force is F. Then for what is the unit positive test charge? What is the force per unit positive test charge? And this we can write as 1 into F by q naught. And this we are calling it as the intensity of electric field or the strength of the electric field. Strength of the electric field or the intensity of electric field can be defined as the force acting per unit positive test charge placed at a point, and that we can write as intensity of electric field. Intensity of electric field means the force acting on unit positive test charge. And if you substitute this one, then E bar is equal to F by q naught is equal to, what is F? K q naught by r square by q naught by r square by q naught. Then q naught get cancelled, and finally what is the value? E is equal to k q by r square. Okay, E bar is equal to kq by r square, or simply we can write k means 1 by 4 pi epsilon naught into q by r square. And this is what we have, the intensity of electric field or the strength of the electric field due to a charge. This is what we have to write here. Okay, we can write this one as the intensity of electric field or the strength of the electric field we define here. The intensity of electric field is defined as the force acting per unit positive test charge. Force acting per unit positive test charge. Force acting per unit positive test charge. Placed at that point. Placed at that point. Placed at that point. Okay, first you write this one. Placed at that point. Okay, this is what we have intensity of electric field. Placed at that point in the field. Okay, this is what we have intensity of electric field or strength of the electric field. Okay, after writing this one, just to draw and finally write E is equal to 1 by 4 pi epsilon naught into Q by R square. Q by R square. First you write this one, copy. Intensity of the electric field, or we can write as the strength of the electric field. Intensity of the electric field or the strength of the electric field. Okay, E is equal to F by Q naught or KQ by R square. KQ by R square. Then what is the SI unit? Already you know E bar is equal to F by Q naught. Then the unit is Newton for Coulomb. Okay, therefore the SI unit is Newton per Coulomb. Newton per Coulomb. This is what we have SI unit. SI unit of intensity of electric field or the strength of the electric field. Intensity of electric field or the strength of the electric field is E bar is equal to F by Q naught, that is Newton per Coulomb. Okay, then how will be the force? How will be the force? Unit positive test charge. Okay, how will be the force? Intensity of electric field due to a positive charge. Positive charge. Okay, this is simply we can write Q naught. Intensity of electric field due to positive charge at a distance r from it. Okay, then how can you find out the direction? మరి ఈ యొక్క డైరెక్షన్ ఎలా ఉంటుంది? The direction of E is nothing but the direction of force. Now what is the force direction that gives the direction of E? That also you can write here. The direction of E at any point is, shall I rub this one? Okay, after this you can write the direction of E. The direction of E bar at any point. The direction of E bar at any point is the direction of force. Direction of E bar at any point gives the direction of force experienced by the charge. Gives the direction of force experienced. Gives the direction of force experienced on the test charge. Okay, టెస్ట్ చార్జ్ పైన ఎటువంటి ఫోర్స్ ఉందో, ఏ డైరెక్షన్లో అయితే ఫోర్స్ ఉందో అదే ఫోర్స్ని మనం ఇక్కడ చెప్పొచ్చు. ఓకే, దిస్ ఈజ్ వాట్ వీ హ్యావ్ ద డైరెక్షన్ ఆఫ్ ఈ. Okay, this is what we have the intensity of electric field due to a positive charge. First you copy.